The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. So today, we're going to review for the test. I don't know about you, but I didn't get a whole lot of sleep last night because WebAssign is having some issues. I'm fully aware of it. I've been in contact multiple times with Cengage. They are working on it. As of yet, I don't know that they have the problem solved. It has to do with graphing, but a very important message for each of you. So if your graphing is working in WebAssign and you're able to complete your assignments, including the graphing, great, you're good to go, okay? If you are not able to graph them, and I can tell that because I can go in and look at everybody's assignment. If you're not able to do the graphs, I'm going to extend basically all of chapter 10 up through Sunday night in hopes that by then Cengage will have the problems resolved, okay? So there you have it. If you have any questions about that, feel free to email me, but basically I'm just going to go through it. There's like 90 students, I think, and look at each person. If they were able to do the graphs, I'm just going to leave it alone, go on as planned. Your test is tomorrow. If you're not able to do the graphs, like I said, I will go back through and extend the sections, everything, the test, etc., through Sunday night. I will say this, make sure before you open the test, whenever you do that, that you're still able to graph things and you can check back on your assignments, because once the test is opened, I don't know that there's a way for me to reset that. So it's like, make sure everything's working before you do that. Okay, having said all of that, we are now going to go to questions from section 10.4, part 2. So let me get there. And we're going to start off with this problem number 16. So this is 10.4, part 2. Okay. It says from the top of the building, a ball is thrown straight up with an initial velocity of 32 feet per second. The equation S equals negative 16t squared plus 32t plus 48 gives the height S of the ball t seconds after it is thrown. Find the maximum height reached by the ball and the time it takes for the ball to hit the ground. So look at the picture. Notice that the path of the ball is parabola or parabolic shaped, okay? So if we're trying to find the maximum height, we're actually looking for the vertex. See where I've got my arrow there? Okay, so that would give us the maximum height, which would be the y value, or actually the s value, and the time at which it reaches that maximum height would be the t value of that ordered pair. So basically what we've got to do, we've got to find the vertex of that parabola, and then we'll go from there. So let me copy that equation, and then we'll switch to the other screen. Okay. All right. So we have an equation in the form of y equals ax squared plus bx plus c. So we're going to use x equals negative b over 2a to find the axis of symmetry, not also the input value of the vertex. Okay, so let's see. We've got a is negative 16 and b is 32. Okay, so x equals negative b over 2a. And I realize that we're using t and s, but the formula, I'm just going to use x for right now. So this would be negative b over 2a, which is negative 32 over negative 32, which is 1. So the axis of symmetry is at x equals 1. Now, if we put 1 into the equation, s equals negative 16 times 1 squared plus 32 times 1 plus 48. We get negative 16 times 1 plus 32 plus 48, which is negative 16 plus 32 plus 48, which is 64. Okay, so the vertex is at 164. 1 stands for the amount of seconds that have happened at when it reaches the maximum height. So going back to the WebAssign page, the height here, it's correct, is 64 feet, but the time, oh, my bad, I did not read the question correctly. I made an assumption. I assumed they were asking for the time at which it reached its maximum height, which would have been 1 second. But it says find the maximum height reached by the ball and the time it takes for the ball to hit the ground. So that time, it does reach its maximum height 1 second after it's thrown, but we want the time at which it hits the ground. Well, let me ask you this. How high is the ball when it hits the ground? It would be at what height? Anybody? Nobody. Okay. The height of the ball when it hits the ground would be 0. So what we've got to do is go back here and take this equation, which I'm going to recopy on the next page. And we want to know at what time does the ball hit the ground. So the height would be 0 when it hits the ground. So basically I have this situation. Okay, now does that look familiar? We could use the quadratic formula to solve this. We want s for the height to be 0. That's when it's going to hit the ground. Well, we've learned some things we can do to make our numbers nicer before we go on. First of all, I'm going to multiply both sides by -1. So I get 0 equals 16t squared minus 32t, whoops, and then minus 48. Also, I can divide each term by 16. So I get 0 equals t squared minus 2t minus 3. So, and granted, I could still take the original or before I've reduced it and plug them into the quadratic formula. It's just that doing these things first makes it easier to deal with once we have it inside the quadratic formula. All right, so what do I know? I know that A is 1, B is -2, and C is -3 respectively. So t equals -b plus or minus the square root of b squared minus 4ac all over 2a. T equals 2 plus or minus the square root of 4 plus 12 all over 2. T equals 2 plus or minus the square root of 16 over 2. T equals 2 plus or minus 4 over 2. T equals 2 plus 4 over 2, which is 6 over 2, which is 3. T equals 2 minus 4 over 2, which is -2 over 2, which is -1. Let me write that a little nicer there. Okay. Now, I'm getting 2 answers for t. Recall that distance can't be negative, neither can time. Maybe in some scientific sci-fi program or something we can have negative time, but in the reality that at least I live in, there isn't negative time. Let's go back to the picture. So the correct time that it reaches the ground would be 3 seconds. What about that -1? Well, if we look at this picture, the ball was right here at the top, 40 feet up in the air. if we were to actually graph this parabola according to this equation, it would also cross the x-axis down here at -1. But the problem actually starts up at the top of the building. So graphically, we could put that -1 in there, but as far as an actual solution in terms of seconds, it would have to be 3 seconds. Okay, any questions on that problem before we go on? All right, we're going to take a look at number 17. Suppose you are a police patrol officer and you have a 316-foot long roll of yellow, do not cross barricade tape to seal off an automobile accident as shown in the illustration. Now, what dimension should you use to seal off the maximum rectangular area around the collision? So we're talking about a rectangle. So I'm going to draw a rectangle, which I'll refer to in a little bit. We know that we have 316 feet of tape to make this rectangle. We want to know the dimensions, so the longer side, the shorter side, and the maximum area produced by this rectangle. Okay. So we've got a rectangle, okay? And the perimeter, the entire distance around it, is 316 feet. Now, let's say I just want to look at 2 of the sides. So this side and this side. Wouldn't that total distance be half of 316, which would be what, 158? Let's see what that's not what I wanted to do. I wanted to do it like this. If we divide that in half, we would get 158 feet. Okay, so this piece plus this piece is 158 feet. Now, consider this. Let's say that this piece of paper is the total of 158 feet, those 2 sides, okay? Let's call the short side X. So if this total is 158 and the short side is X, what do I have left? I have 158 minus X. You still with me? So that means that let's see, this might be the length and this might be the width, okay? So we've got the area, and I'm going to write this using function notation, is the length times the width, okay? Which gives me A of X equals 158X minus X squared. I'm going to go ahead and write that function in descending powers form. Okay, so here's the function I'm going to use. Now, notice that's a second-degree equation. So its graph would be a parabola. A is a -1, so it's going to open. And in fact, the graph would look roughly like this. Okay, very roughly. Now, my 2 variables are X, which is the width, and A of X, which is the area. So this is the X-axis, and this is the A of X-axis. So my maximum area would be the highest A of X value on the graph. In other words, the output of the vertex, okay? When will that occur? When the width is whatever the input of the vertex is. Or what I'm trying to get at here is I need to find the vertex of this parabola. So let's take that equation and go to the next page so we have more room to work with. -X squared, and then it was plus 158X. Okay. Let's see here. All right. So now I'm going to use x equals negative b over 2a, where a is -1 and b is 158. So this is negative 158 over 2 times -1, which is negative 158 over -2, which is 79. All right. So what is 79? That is the input of the vertex. Okay. Now, how do we find the output? Well, we find a of 79, which is negative the quantity 79 squared plus 158 times 79. And it's calculator time. Notice that the negative sign is outside of the square. So 79 times itself is 6241. But then that's negative, plus 158 times 79, which is 12,482. And if I take that and combine them, 6241, I get positive 6241, and that is the square feet. So x is 79 feet. Let's see, the other dimension was 158 minus x. 158 minus x would be 79 feet, and the maximum area is 6,241 square feet. So in fact, notice that the shorter side and the longer side are both 79 feet, which means that our rectangle is a square. And then some people say, well, first of all, is a square a rectangle? Yeah, not all rectangles are squares, but all squares are rectangles. A square is a rectangle with 4 equal sides. And then the question comes up, why didn't they just tell us it was a square? Well, if they told you it was a square, all you'd have to do is take 316 and divide it by 4 and you'd be done. And that would just be too easy. All right, anyway, so we've got our maximum area of 62, let's see here, 6,241 square feet. I added the squared there. I didn't have it before. And our dimensions are 79 feet by 79 feet. Any questions on that before we go on? Okay, we're going to go on to number 18. A farmer wants to fence in 3 sides of a rectangular field shown below with 1,200 feet of fencing. The other side of the rectangle will be the river. If the enclosed area is to be maximized, find the dimensions of the field. First of all, I'd like to say that the farmer is not real bright, because anybody that raises cattle knows that you can't just assume that the cows will not go into the river. So what can I say? But I guess for this problem, we'll make that assumption. Actually, it doesn't say the cows will stay in. It just says they're building this fence. So we've got 3 sides of a rectangle. Okay, so let me draw that picture, which I'll refer to in a bit. Now, the total distance of fence is 1,200 feet. Okay, but we're not actually going to build all 4 sides. We're only building 3 sides. Okay. And again, we want to find here, they just want the dimensions of the rectangle. They're not asking for the total maximum area. Okay, so let's go back to our other screen. And now, let's go back to our piece of paper that represents, so this is 1,200 feet of fence, okay? But I'm going to build 3 sides of a rectangle. So let's see here. I know I should have studied that origami more closely. So our picture kind of looks like this. We've got these 2 equal pieces and then this longer piece down below. So looking at my whiteboard here, I'm going to call each of these X. Since it's opposite sides of a rectangle, they're going to be the same size. And then I've got this long piece. Well, the whole thing is 1,200 square feet. No, excuse me, 1,200 feet. So if I've got 1,200 feet minus x minus x. The piece in the middle is 1200 minus 2x. And that's where I get my dimensions of the three sides of the rectangle. So I've got x, x, and 1200 minus 2x. Any questions about that? All right. So again, area is length times width. And I'm going to put this in standard descending powers there. I keep wanting to say.
Wait.
Yes.
Wait. If it's 1200 minus 2x times x, wouldn't that be 200 or 1200x? Yeah. Okay.
Thank you, Sage.
Yeah.
Yes, it would be. Yes, it would be. All right. In fact, this would be like that. So I've got all kinds of missing things. I'm still having a Monday, even though it's Thursday. All right. So negative 2x squared plus 1200x. Half of my mind is focused on what am I going to do if they don't get WebAssign fixed? Okay. So here is our function. And it's, I keep wanting to call it standard form, but this particular book doesn't call this standard form. So that's why I kind of keep jarbling the vocabulary. All right. Again, we need to find the vertex. The x value will be the, let's say, width, and the a of x value will be the maximum area. Now, they don't actually ask us to find the maximum area for this problem. So really, we just need to find the axis of symmetry, which is x equals negative b over 2a. And we've got a equals negative 2, b equals 1200. So we've got negative 1200 over 2 times negative 2, which is negative 1200 over negative 4, which is what, 300? Okay. So this side is 300 feet. This side is 300 feet. This side would be 1200 minus 2 times 300, which would be 1200 minus 600, which would be 600 feet. So your dimensions are 300 feet by 600 feet. Okay, now let's go back to the WebAssign screen. It asks for the smaller side, so that would be the 300 feet, and the larger side would be the 600 feet. Any questions on that one before we go on?
Can you go back to the slide real quick?
Mm-hmm. That one or yeah, I guess the whole thing is on there.
Yeah, that one.
Any questions there? Just need to look at it.
Yeah, I just need to write it down.
Ready? Let me know when you're good to go.
Good to go.
All right. Number 19 coming up. And let's see here. '19 says the total annual enrollment in millions in a country's elementary and secondary schools for the years 1990 to 2011 is given by the model E of X. E of X equals 0.058x squared minus 1.162x plus 53.502, where x equals 0 corresponds to 1990, x equals 1 corresponds to 1991, and so on. For this period, when was enrollment the lowest? Okay, now we are looking at trying to get my mouse to move in the right, there we go. We're looking at another quadratic or second degree equation. This one has a leading coefficient that is positive. So that means the graph is going to be opening upward, okay? Whereas this axis would be X, which corresponds to the year, and this axis would be E of X, which corresponds to the enrollment in millions, all right? So this is X and this is E of X. Now, it says, for this period, when was the enrollment the lowest? So the when would be what time, what year? So the X value. So again, we want the vertex. The X value would tell when, the Y value or the E of X value would tell what that low enrollment was. So we're going to use X equals negative B over 2A, and A is 0.058 and B is negative 1.162. So I've got negative times negative 1.162 over 2 times 0.058. Okay, so X is going to be what? 1.162 over, hang on here, let's see what we've got. We've got 2 times 0.058, and that's 0.116. Now, I'm going to take 1.162 and divide it by 0.116. And when I do that, I get 10.0172413.8. Wow. Okay, before I go on, I'm going to double check my numbers here just to make sure I didn't make a mistake, since I tend to do that. I've got the equation copied correctly. A is that, B is that, negative B over 2A. So that looks all right. Okay, so now the question is, you know, so that's, let's see, what is that? That's the year, okay? So which is what, 10 point something. Well, going back to the problem, if X is 10, that would be 10 years after 1990, which would be the year 2000, okay? So the year 2000 is when the enrollment was the smallest, okay? Now, we're going to go back to the second part. It says, what was the enrollment? Round your answer to 1 decimal place. Well, I'm going to be bold here, and I'm going to just take 10, and I'm going to find E of 10, and let's see what happens when I do that. Okay, so I've got, in other words, I'm not going to drag this whole thing through the problem. So I'm going to take 0.058 times 10 squared minus 1.162 times 10 plus 53.502. Doing all that calculations, 0.058 times 100, right? Minus 1.162 times 10 plus 53.502. Okay. And when I do that, I'm getting 47.682. And it said to round to 1 decimal place. So the 8 would round up, so you'd get 47.7, and that's million students. Okay? So in the year 2000, there were approximately 47.7 million students, which was the lowest enrollment during that time period. And if we were in some other class, sociology or whatever, we might study why was that the case, but right now we're just doing the math. Okay, any questions on that before we go on? Number 20 coming up. And here we go. The revenue R received for selling X stereos is given by the formula R equals negative X squared over 4 plus 60X minus 1200. How many stereos must be sold to obtain the maximum revenue? Find the maximum revenue. Okay, so X is the number of stereos and R is the revenue or the money generated. Okay, now again, we have a second degree equation and its leading coefficient is negative, which means its graph is going to open downward. Okay, this axis is X, which is the number of stereos. This axis is R, which is the revenue. So if we find the vertex of the parabola, the X value will be the number of stereos. The Y value will be the R value will be the revenue generated. Okay, so A is negative 1/4 and B is 60. X equals negative B over 2A, negative 60 over 2 times careful, negative 1/4, which is negative 60 over 2 times negative 1/4 would be negative 1/2. Well, negative divided by negative is positive, and 60 divided by a half is 60 times 2 over 1 is 120. So X equals 120. So that's the number of stereos that will achieve the maximum revenue. Okay. Now, to find that revenue, we want to find R of 120. So we're going to say R equals negative 120 squared over 4 plus 60 times 120 minus 1200. And let's see, we'll put that in a calculator. Negative 120 squared divided by 4 plus 60 divided, or whoops, not divided by, times 120 minus 1200. And I come up with 2400. Now, be careful. Here, this negative is not inside the square. So you're going to square the 120 divided by 4, and then that negative sign is outside, or I put it into my calculator, you know, like that kind of thing. All right. So this is the, let's see, this is maximum revenue. They don't tell us what units, if this is dollars or hundreds of dollars or millions of dollars, which is unfortunate. But so for this problem, if you sold 120 stereos, you would maximize your revenue at 2,400 whatevers. Oh, I see that on WebAssign it has a dollar sign on the response right over here. However, they didn't really say, it should have said how many stereos must be sold to obtain the maximum revenue in dollars or something like that, but it didn't. Okay, we all right on question number 20? Okay. So now we're going to go to some questions from the chapter review. Let's see here. Okay. And starting with problem number 12. Okay. So chapter review number 12. Use the quadratic formula to solve the equation. Enter your answers as a comma-separated list. So we've got x squared over 12 minus x over 6 equals 1/2. All right. First thing I'm going to do is put this thing in standard form, so to speak, everything on one side with descending powers of the variable equal to 0 on the other side. So I'm going to subtract 1/2 from both sides, which gives me x squared over 12 minus x over 6 minus a half equals 0. Okay. Next thing I'm going to do is clear the fractions by multiplying both sides by the LCD, which is 12. So I get 12 times x squared over 12 minus 12 times x over 6 minus 12 times a half equals 12 times 0. Going through and reducing, I get x squared minus 2x minus 6 equals 0. So let me recopy that. X squared minus 2x, oops. Minus 6 equals 0. Okay, so now I'm ready to use the quadratic formula where a is 1, b is -2, and c is -6. So x equals negative b plus or minus the square root of b, the quantity squared. So here the negative is inside the square, minus 4a c all over 2a. Okay, x equals 2 plus or minus the square root of 4 plus 24 all over 2. X equals 2 plus or minus the square root of 28 all over 2. Now, some of the problems ask you for decimal approximations. Some of you don't, or some of them don't. If it doesn't, which this one doesn't, you want to get the exact answer and you want to get it, or answers, and you want to get them reduced down as much as possible. The square root of 28 is the square root of 4 times 7 is 2 square roots of 7. So this becomes x equals 2 plus or minus 2 square roots of 7 over 2. Okay, but I could rewrite that as 2 over 2 plus or minus 2 square roots of 7 over 2, and that would reduce down to 1 plus or minus the square root of 7. This would reduce to 1, that would reduce to 1. 1 times the square root of 7 is the same thing as just the square root of 7. So x equals 1 plus the square root of 7, comma, 1 minus the square root of 7. Okay, so there's your two answers to that particular problem. Any questions before we go on? Okay. Now we're going to take a look at problem number 18. Okay, now, it looks to me like the problem here was they got the vertex correct, they got the axis of symmetry correct, but when they went to plot it, their second point was incorrect. So let's do this. Let's get the screen going. F of x equals the quantity x plus 4 squared minus 2. Okay. Now, oops. The vertex is at h, k, which would be -4, -2. The axis of symmetry is at, and again, make sure for your axis of symmetry that you put an equation, x equals. If you just put -4, it's going to be marked wrong. It's got to be x equals, because it's a dotted line, a vertical line that's not part of the graph, it's just part of the reflection. Okay, now, this particular student, it looks like they used x as -8. So let's see what happens if we put in, well, -8. So f of -8 would be -8 plus 4 squared minus 2, which is -4 squared minus 2, which is 16 minus 2, which is 14. So this graph, let's see here. So -8, 14, that would have been another point on the graph. However, this particular grid doesn't go up to 14. So I'm not sure what would happen. So again, my advice would be to pick something close to the vertex. So let's go back. Since our vertex was at -4, -2, so in our ordered pair table, we'd have that. How about if we pick either -5 or let's go with -3? Maybe just one integer to the right or the left of the vertex. Okay, so let's see what happens when we do that. That should give us a nicer value that's easier to graph. Okay, so f of -3 would be -3 plus 4 squared minus 2, which is 1 squared minus 2, which is 1 minus 2, which is -1. So that means -3, -1 would be another point on the graph. So here, our vertex would be at -4, -2, and then -3, -1 would be right there, and then that would have given us the correct answer, okay? So you were okay, except for your second x value. Your calculation was off for some reason. Again, make sure you graph the vertex first, all right? 19. Looks like they just didn't graph it. So what you do with that, let's see, we've got f of x equals negative the quantity x minus 11 squared. Okay, so your vertex is at 11, 0. Where did I get the 0? Well, k, which is out here, is just a 0. And h is the 11 because it's x minus h inside. So there's your vertex. Your axis of symmetry is at x equals 11, and that part was all correct. So then to graph this thing, what I would do is I'd say, well, let's pick something to the right or the left. How about to the right? So what's f of 12? Okay, -12 minus 11 squared, which is -1 squared, which is -1. All right, so then going, back here, there's our, let's see, our vertex is at 11, 0. So we click over here, we click on the parabola button, get it blue, 11, 0, and then 12, -1. And if it doesn't graph exactly, you can come over here and click on the graph once it shows up, and you can go in and change the ordered pairs. We talked about that before. Okay. Let's see here. Now we're going to go down to number 30. Okay, 30. This is pretty much the same kind of problem. Let's see here. Yeah, in fact, this is the exact same problem. Sometimes the numbers that get generated are the same. This is the exact same problem as number 16 on 10.4 part 2. So I'm not going to redo that one. Okay, 31 is going to be just like, let's see here. Hang on, where is that? Find it here. Where do we have the rectangle? Okay. Yeah, okay. So, number 17 that I did earlier is just like 31. The only difference is this, instead of 316, is 268. So you're going to take 268 and divide it by 2 and get whatever that number is. This is going to be x. This is going to be whatever that number becomes, minus x, etc., etc. Okay? So the person that asked about that, if you still have issues with that, contact me, but it's the same exact problem. And then problem 32. Again, that's going to be like, let's see here, like problem number 18 from the exercises. Only now, instead of it being 1,200 feet, it's going to be 800 feet. So you're going to have x 800 minus 2x. And from there, everything should be the same. Okay. So again, 30, 31, and 32 are very much like, what was it? 16, 17, and 18, I think it was from the assignment or something like that. Anyway, so we've basically done the same problems, just different numbers. Okay. Let's see. I want to look, I've got time for about one more problem. And so I had another student's requests. A lot of them are the same problems. But let me see, I think they had one other one that was different. Okay, 10.4 part 2. They asked for 15. Let's see about that. Sorry, I'm mumbling here. Okay. Yeah, let's take a look at this one because we didn't do one like this. So this is back to section 10.4, part 2. We're going to look at number 15. A fireworks shell is shot straight up with an initial velocity of 80 feet per second. Its height s after t seconds is given by the equation s equals 80t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? Remember earlier when I was doing the building one and I found the time of when it reached its maximum height, and they wanted to know when it hit the ground. In my brain, I was thinking about this problem. Here they want to know the maximum height and when it reaches the maximum height, not when it hits the ground. Okay, so let's go back here. We've got this equation, which I'm going to rewrite like this. And this is a parabola opening downward. So the vertex would give us the time at which it reached the maximum height and the maximum height, because your ordered pairs would be in the form of t comma s. Okay. A is negative 16, B is 80, x equals negative b over 2a, negative 80 over 2 times negative 16, negative 80 over negative 32, and negative divided by negative is positive. 80 divided by 32 is 2.5 seconds. So that's how long it takes to reach the top till the fireworks explodes. How high is it? Well, that would be negative 16 times 2.5 squared plus 80 times 2.5. And on the calculator there, we get negative 16 times 2.5 squared plus 80 times 2.5, which comes out to 100 feet. So the vertex is 2.5 comma 100, and 2.5 seconds after it's shot off, it's 100 feet in the air, the firework explodes, and everybody goes, yay. All right, well, I think I did just about every question that was asked. I know I didn't do both, you know, the ones I did, some of them had different numbers than what people asked for, but it's the same idea. Anyway, I'll be back at 1:15. If you still have any questions, email me or show up then. Again, I am going to go through and extend people who are having trouble with their graphs because of WebAssign not working correctly. I'll go in and extend your time through Sunday night, and hopefully that will take care of the problem. If it doesn't, well, we'll figure it out. All right. Anyway, have a great rest of the day. And don't forget, those of you, well, the test is scheduled for tomorrow. All right. Oh, so I won't be back here tomorrow morning at 10:30, but I will be here during my office hour. Okay. Blah, blah, blah. See you later.